Hi, welcome to knowledge base video on Introduction to Embedded System. Before starting up with the theory and concepts of embedded systems, let's go back into some history. Back in 1950s, the computers were huge in size and used to occupy entire floor of a building and used to weigh tons. These computers were built using vacuum tubes which used to produce lot of heat, and for storing data and programs, magnetic tape and punch cards were used. And people has to load punch cards in order to operate a particular program. In 1960s, when Apollo moon landing program started, uh, they were in need of a computer to guide them to land on moon, and they called this system as Apollo Guidance Computer. Finally, they did build Apollo Guidance Computer, and it is considered to be the first modern real-time embedded system. During that time, silicon technology was still in labs and magnetic tape and punch cards were not reliable. The challenge for them was how to miniaturize this huge computer to fit into the rocket. They came up with different technologies in the process, and one of the breakthrough was magnetic core memory or rope memory. This magnetic core or rope memory used to work like this. They had to send the software to to the company, and they had to weave the software by hand into the magnetic cores. By the end of 1960s, they had successfully come up with the computer system which had DISCI interface. DISCI is actually display and keyboard, which has only a couple of lines of display and keypad. This computer had 2048 words of erasable magnetic core memory and 36 kilowords of read-only core rope memory. And they used almost 7,000 ICs of 3-input NOR gates. That's how first modern embedded real-time computer was built. In 1969, Busicom, a Japan calculator manufacturer, came to Intel and asked to manufacture different integrated circuits for each of their calculator model. But Intel proposed a single IC solution which could be used in all their calculator models just by changing code. Basically, that is how the software came into picture. So all you had to do is, for the same IC, if you change the code or instructions for it, it used to work as a different calculator. And thus first commercial microprocessor 4004 was born. And in 1971, Intel introduced 4004 to the world, and the era of single chip microprocessor started. Today we have so many varieties of microprocessors and microcontrollers from different manufacturers. Okay, let's come back to what is embedded system. Embedded system is just a small computer which is designed to do only a particular task. So in theoretical answer, embedded system is a software hardware combination along with electromechanical components together performing a specific function. Now to answer why do we need embedded system, it is very simple. You can't install a computer inside a microwave oven just to take care of cooking time and power required. And it's similarly for a washing machine, you can't have a big hardware just to take care of the timer and washing cycles. Similarly for other products also, if you think we just need some basic functionality just to control something or to automate something, you cannot have an entire system which consumes lot of power and lot of space. To put it in simple terms, embedded solution is used in the systems where processing power is very minimal and it does very specific task. Okay, to give you some idea on how these embedded hardware differ from general purpose computer, here I have some hardware stuff to show you. And this is a Pentium 3 motherboard, and I have a processor. This is a Pentium 3 processor, you can see. and this is the RAM for this motherboard which sits here. Okay, so why I'm showing you all these things is there is a huge difference. See, this general purpose computer, you can have this Pentium 3 is probably it's not written, but yeah, this motherboard could support up to 1.2 gigahertz of Pentium 3, so you can have up to that processor. I mean, like, you can upgrade that. You can upgrade RAM for this. So there is 2 slots here. You can have one RAM here. This is actually I don't know, it's not written, probably 128 MB RAM or something like that. If you want to upgrade to 256 MB RAM, you can buy one more RAM and put it here. And see, okay, let me keep it. And see, there are a lot of other options. This is like these are called as PCI slots, where you can have some extra hardware if you want to connect. For example, an Ethernet. See, this motherboard doesn't have Ethernet connection. Okay, so if you want Ethernet capability to this motherboard, all you can do is, like, you have to buy this PCI board. This is actually Ethernet board, LAN card, what they call, and all you have to do is, like, install this hardware like this to any of the PCI slot and install a driver which comes with this. Because of this hardware and software combination, where you have operating system sitting on top of all this hardware, and you can write almost any drive, like you can interface to all these slots. You can write any driver. Like, if you want to connect a video card, you can have this. This too has limitations. Some limitations are there, like you can't put a Pentium 4 processor into the slot, something like that. But yeah, see, the idea is you can have almost like almost all kind of software. You can write software. You can use this computer for video editing, or you can use this computer only to monitor something, or you can have to you can like install some programs to watch movies. A lot of things. Like, see, the options are unlimited. Just because of the hardware and software, it is limited only to the hardware and software. So in case if you want to use this hardware for gaming, probably you may have to install a video card. And this is PCI Express type 1, I guess. Like I don't know, like, how it is, what it is. Okay, and I would like to show you one more motherboard. Okay, and this is the motherboard. Okay, so here you can see this is a PCI, this is AGP slot. This is where you connect your video card or a graphics card, what we call. And this has a lot of inbuilt USB, Ethernet slots and all. Okay, so see, here you can see there are like 4 RAM slots. And all other hardwares, like optical disk drive and hard disk, you can connect to these slots. Probably when IDE was there, the maximum you would get is like 500 GB hard disk, I guess. So, but that's the idea. So limitations of usage is only with respect to software and operating system and hardware what you have. That's it. But other than that, you can use this for almost all applications. You can write any application you want. So this is what general purpose hardware look like, and I would like to show you hardware of a tablet. Okay, this I have ripped open, and this is display. This is the display, and this is a backlight of the display, and these are the LEDs. LED strip I have. Okay, I have removed all this. Let me keep this aside. Okay, here we go. So this is actually an embedded system. You see, because of the limitations, you can't actually add any other hardware other than this. Even in the software, it is limited only with respect to what Android gives. And actually, this tablet had Android Froyo, I guess, and that's it. So yeah. Okay, so if you see carefully, I'll zoom in here. Okay, if you say this particular board which is soldered here, this is actually single board computer. Actually this has processor, this is the processor, and this is Hynix RAM, and these two are RAM or ROM, sorry, these two are ROMs, NAND or NOR ROMs. Usually it will be one of them will be NAND and one of them will be NOR. Yeah, okay. So this comes under embedded system because of the limitation with hardware and software. Okay, you can't just write a software which utilizes which goes beyond the hardware capability. Even in general purpose it's the same, but yeah, general purpose is like friendly for the developers who can because of the operating system. But yeah, here it is limited with respect to the SDK what you get. Actually, if you are developing for this tablet, you are limited with respect to the functionality provided by Android Froyo. Okay, so let me zoom out. Okay, so here if you see, there are a lot of hardware. This is actually wireless module. This is both the Wi-Fi and Bluetooth module, and there are a couple of connectors. This is for the display connector, and yeah, see, you can't just bring a display like 20 inches display and you can't connect here. This has limitations. So there will be a driver. See, this is actually a VIA chip driver. You can see here this is a VIA chip. So this VIA chip is what it is driving, I guess. Either this is okay, let me confirm on that. But VIA chips has video drivers. Okay, video hardware and all. Okay, so there are limitations for these things. So that is why this comes under embedded system. But because of the Android hardware what we have today, or even Linux, Ubuntu operating systems which are coming up for embedded systems today, because of ARM processors like Snapdragon and all, which are going up to 2 gigahertz, we are actually blurring the line between embedded system and general purpose computer. Okay, so let me show you some other hardware. Okay, so here we have some interesting hardwares. Okay, before going for this hardware, I would like to show this mobile. Okay, see, this mobile is actually a good example of embedded system. Actually, see, there is all the hardware what it is there inside, it does only one particular job. So they are limited for the task of calling and sending SMS and storing some number, something like that. So see, this is a keypad which you can remove this, and there is a connector. Okay, I'll come to all those things later. Okay, this is the display, and you can see this display soldered here. Okay, and here is the hardware. Yes. Okay, so these are the chips. This is like embedded hardware, and if I open this, you can see the GSM chips. See, this is Qualcomm's MSM 6000 chip. Okay, so this is what it is. Actually, this is what it is communicating with GSM, and there are some couple of other chips which is supporting the display and power supply, taking care of battery charging and all. And yeah, see, this is a perfect example of embedded system, because you can't add any of the hardware here, and you can't add any software also. See, this is limited. This will have a firmware which is working, and you can't add some other functionality by yourself or any developer. This has to be come from the company which has manufactured. Okay, so one more example is this one. This is a GPS tracking system, and okay, so here is the processor. Okay, this is using microchip processor. This is microchip processor. I don't know if you can see this, or else I'll give you, or else I'll. Okay, here you go. Okay, I hope you are able to see this as microchip. Anyway, it doesn't matter. I'll show you later, like when I'll show my when we start with microcontroller programming, I'll show all those things. Okay, so this is microchip 8-bit processor. Yeah, PIC18. This is 8-bit processor, and this is the communication board. Like okay, and this is actually this is wireless module. That is all it is written. Anyway, so I'll show you one more. Okay, so these are actually the perfect example of embedded system. Okay, and okay, here you go. This hardware is actually this is also a GPS tracker, but you can actually program this. This is like you can buy one of this and program this. There is a USB port and there is a software given with this, so you can program this to send the data to whichever server you want, or if you want to send this data, send the location of this device to your mobile, you can do that. Okay, so here you see this is uBlocks. Yeah, this is uBlocks GPS module, and this is Teltonika. Okay, Teltonika GPS system. Sorry, GSM system. Okay, so if you see back, okay, I broke this anyway. If you see back, this is ARM processor from ST, and there are a couple of other hardware and diodes and a lot of other stuff. This is the crystal to drive this. Okay, what is the crystal? I'll speak about it later. Okay, so this is the power supply design and okay, so this is actually a perfect example of embedded system. All it does is like take the location, note down the location, and send it to the destination, like your server or your mobile, something like that. Okay, so that is all it does. So the embedded system is basically built for specific task, to complete a specific task. So you can't just upgrade anything. If you want a good, like if you want a processor which exceeds like 1 GB and all, 1 gigahertz and all, you can't just upgrade here. Okay, so that is how these things are. You have, that is the limitations of embedded system. Okay, so hope I think you got a fair idea on what is this general purpose computer and embedded system is all about. Why we have so much of variation, what is the variation basically, what is the difference and all. Okay, so here is a special case. This is Raspberry Pi B plus model, and this is, they call this as a single board computer, because you can have there are a lot of operating system built for this particular model. I mean, like Raspberry Pi, you can have Raspbian, and you can install Ubuntu, I guess, and there is what you say, Arch Linux and all. There are a lot of operating system available for this, but this is also an embedded system, because you can't have anything added to this, and there is a limitation for this. Okay, so the GPIO lines of the processor is been out here, like this is 40 pin GPIO lines strip, and you can see here this is actually having 4 USB and one Ethernet port, and this is the memory card where you install operating system and everything, and that's it. So see, this is one good example which falls in between both embedded system and general purpose computer. So that is why they call this is a single board computer, and you can connect it to TV through HDMI or composite RCA. This has a RCA, like this is 4-pin jack which has RCA for video, audio left and right. Okay, and they have camera connection here and display connection here. I did this, and the tablet what I showed you falls in between general purpose computer and embedded system. Okay, so to conclude, I think you might have got some fair idea on what is this general purpose computer and embedded hardware. So one more thing I wanted to tell you is, see, there won't be any extra this embedded board doesn't have any external memory here. Probably EEPROM will be there to log all the things. I think this is the EEPROM which logs data in case of connectivity is not there, in case if there is no connectivity with the server, something like that. And all the firmware for this to operate, whatever software it has been written, will be sitting inside this microcontroller itself. Microcontroller will have ROM and RAM inbuilt along with the processor and control units. There will be a lot of peripherals like ADC, timers, and also probably this will have RTC, real-time clock, because it has to take care of the time, because it is a logger. So, and you can have connections here, like for if you want to measure the fuel gauge and all, you can have something. If it is like engine start or off, all these things will be logged by this particular model. And for all those things, the firmware is inside the chip itself. For development, we have a lot of embedded kits available, development kits available from most of the companies like Microchip, ARMS, and other stuff, like locally also available. And for hobbyists, we have Arduino like this. And for engineers, like if you are doing some coding, really if you want to code everything, we have small kits like this, which is just a breakout board. There is IC, and this is a crystal for that, and basic stuff connected, like power connectivity, like here there is a connectivity, and that's it. All this is pins are broke out like this, and you can use this to connect with any other things. So for developers, if you want to learn ARM, there is ARM development kit. For like PIC18, there is a PIC18 development kit. Like this is available almost in all electronics and hobbyist market. But see, the development board will cost you like 3,000 rupees, which has almost all like keypad, display, and all. But we are going to start with basic kits like this. Okay, so we are going to build this one. This is for just to show you, and this is Atmega board, but we are sticking with PIC microcontroller. So this is the board what I am going to use, and this has I replaced this socket. There is basically a socket to install the chip that I have removed and installed as ZIF socket. ZIF is zero insertion full, so I can unlock this, take it out, put it in the programmer, program this, and put it back here. This is what this is how I started learning microcontroller, and this is the kit which I will be using to initially to show how to program, and then we are going to construct this board. Okay, that will be handmade, not a PCB manufacturing process and all. Okay. Okay, so this is what I wanted to tell, like all these things are available. I'll put some links for kits on development kits and all, which is available in Bangalore. It is available with NSK and Home Technology Center, and there is Lakshmi Enterprise and all. There are a few of them. Okay, I'll put the links at the bottom of the video. Okay, this is from NSK. This is NSK PIC demo board. Okay, yeah, that's it. Okay, thank you.